You know that thing you do every day without even thinking about it? Waiting in line? Well, what if I told you that simple, everyday act is the secret to how your printer, your computer, and pretty much the entire internet works? It's all about the power of the queue, and today we're going to break it all down. I mean, really think about it for a second. You and your colleagues send like a dozen documents to the office printer all at once, or a website gets a million hits in a single minute. How does it all not just crash and burn? The answer is so much simpler than you'd think. Technology is really, really good at waiting in line.
And that's what this is, really. It's the universal waiting game. Doesn't matter if you're waiting for your morning coffee or if a piece of code is waiting for its turn to run, the basic principle is exactly the same. And it's this simple, brilliant idea that technology has borrowed to create perfect order out of total chaos.
At the end of the day, it all boils down to one simple, unspoken rule: fairness. First come, first served. It's something we all get, right? And this intuitive idea is the absolute bedrock of how computers manage these massive workloads in a way that's predictable and orderly. And of course, in the world of computer science, we have a formal name for this. It's called first in, first out. You're going to want to remember that one. This golden rule is the engine quietly humming behind some of the most complex tech we use every single day. Okay, so here's the official textbook definition. But don't let the fancy words scare you off. Linear data structure? That's just a geeky way of saying a straight line. Just picture a checkout line at the grocery store. You get in at the back, the rear, and you leave from the front. That's literally all it is. Seriously, if there is one thing you take away from this explainer, let it be these four words: first in, first out. Or, as programmers call it for short, FIFO. This is the heart and soul of what a queue is all about.
So, you know how there are rules in a real line, right? No cutting. Well, digital lines have rules too. Let's take a look at the three basic commands for getting in, getting out, and, well, seeing who's next.
First up, enqueue. It sounds complicated, but it just means get in the back of the line. Simple. When it's finally your turn, you dequeue. That's you leaving the line. And then there's peek. That's like standing on your tiptoes to see who's at the front without actually getting out of your spot. Enqueue, dequeue, and peek. That's the whole game. And check this out. This is what it actually looks like in the real world. This is a little snippet of Java code. And as you can see, those operations are just simple one-word commands. It's pretty amazing how elegant and efficient this whole system is when you see it in action.
But, a simple line isn't always the right tool for the job. What if you need a VIP line, or a line that has to be super efficient with the space it uses? For situations like that, computer scientists have cooked up some really clever variations.
This slide breaks it down perfectly. Your simple queue, that's just like a single toll booth lane. First come, first served. Then you have a priority queue. Think of a hospital emergency room, where the most urgent cases get to go first, no matter when they arrived. And then there's the dequeue. That's a double-ended queue. It's just like your browser history, where you can add or remove from either end by going back or forward. And then there's the circular queue. Now this one is really clever. It's a design where the end of the line actually connects back to the front, creating a loop. This is incredibly efficient for systems with a fixed amount of memory because it makes sure that absolutely no space goes to waste. All right, enough with the theory. Where do you actually see these things in your daily life? Let's pull back the curtain and see how this humble little queue is the invisible engine powering the technology you use every single day. Okay, so every single time you hit print, your document goes into what's called a spool, which, you guessed it, is just a queue. Your computer's brain, the CPU, uses queues to manage all of its tasks so they run in an orderly way and don't trip over each other. And that video you're streaming? A queue is working behind the scenes as a buffer, making sure you get a smooth, uninterrupted playback. So really, you can think of the queue as the unsung hero of computing. It's this simple, elegant system that silently brings order to the potential chaos of all our digital requests, making sure everything is fair and efficient. And look, it's that simple again. This one little line of code is literally all it takes for a developer to spin up a powerful queue. It's just a beautiful testament to how fundamental and elegant this concept really is. Now, of course, nothing's perfect, right? Queues have their trade-offs. The huge advantage is that you're guaranteed fairness and order.
The limitations, like having a fixed size or not being able to just grab an item from the middle, are really just design considerations. And that's exactly where those clever variations we talked about, like the circular queue, come into play to solve those specific problems.
All right, let's bring it all home. What's the final takeaway from our little journey into the world of queues?
Here's what you really need to remember. 1. The golden rule is first in, first out, FIFO. 2. The core moves are enqueue to add an item and dequeue to remove one. And 3. Their impact is absolutely massive. They are the silent organizers in everything from printing documents to streaming videos.
So, we'll leave you with a little puzzle to think about. Now that you know the rules of the game, how would you go about designing one of those circular queues to make sure it perfectly reuses every single spot in an array? It's that kind of thinking, taking a simple idea and refining it, that turns these fundamental concepts into incredibly powerful technology. Thanks for joining us.